Okay, so at this point we have laid out what a sequence is. We've talked about how to define some of the terms of a sequence, and we've also looked at, in my opinion, the more difficult scenario in which we are given terms of a sequence and we must come up with a formula for that sequence. One other general thing I want to talk about with a sequence is there are particular types of sequences called recursively defined sequences. Okay, and all this means is that each term depends upon the previous term. Okay, so let me go ahead and show you what one of these will look like. So for example, let's say we had the sequence a sub 1 equals 5, and then the general form of this sequence is going to be a sub n is 2 times a to the n minus 1 plus 3. Okay, and let's go ahead and we'll define the first 5 terms of this sequence. So a sub 1 we already know is 5. Okay, a sub 2, the way that we would find this is we would do 2 times a sub 2 minus 1 plus 3. Okay, well a sub 2 minus 1, that's a sub 1 plus 3, and we already know a sub 1 is 5. So it's 2 times 5 plus 3, that would give us 13. Okay, if we look at a sub 3, all this means is, think about what a sub n minus 1 means. That means go to the previous term, because 3 minus 1 is a sub 2. So if I go look at 2 times a sub 2 plus 3, well, a sub 2 is 13. So if I look at this, 2 times 13 is 26, plus 3 is 29. Okay, so all I'm really doing here, if you think about it, is I'm going back to the previous term. So if it's a sub 4, I need to go back to a sub 3, multiply it by 2, and then I'll add 3. Okay, so 2 times 29, that's 58, plus 3 is 61. So if we start to list out some of these terms, 5, 13, 29, 61, the way that we got the next term is we took the previous term, we multiplied it by 2, and we added 3. 5 times 2 is 10, plus 3 is 13. 13 times 2 is 26, plus 3 is 29. 29 times 2 is 58, plus 3 is 61. 61 times 2 is 122, plus 3 is 125, and so on and so forth. Okay, so we call this a recursively defined sequence when each successive term depends upon what we had as the previous term. The reason why we have to define the first term is because if every term depends upon the previous term, if we didn't know the first term, we wouldn't know how to start our sequence. Okay, so by defining recursively defined sequences, this allows us to actually look at a couple of different specific types of sequences. And in this unit, there's only 2 that we're going to discuss, and they are arithmetic and geometric sequences. So let's start out with an arithmetic sequence. Okay, so we're going to define this right now. An arithmetic sequence means there is a common difference between each term. Okay, there's a common difference between each term. So let me write out an arithmetic sequence for you. For example, 2, 9, 16, 23, 30. This is an arithmetic sequence because what you'll notice here is to get from one term to the next every time, all we did was we added 7. Okay, we started with the first term and we added 7. Okay, the way that these can be defined recursively is pretty simple. We start out with our first term, we'll call that a sub 1. So I'm just going to say a sub 1 equals a sub 1. And then to get to any of our further terms, we go back to the previous term, which the way that that looks is a sub n minus 1. So all this means is go back to the previous term and then add the common difference, which we'll call d. Okay, so like if we're defining these, a sub 1 is the first term and d is the common difference. Okay, so like if we're looking at this particular arithmetic sequence up here, if we wanted to define this one, well, a sub 1, the first term was 2. A sub n is go back to the previous term and then add, in our case, 7. Okay, so this sequence right here has an initial term of 2 and it's got a common difference of 7. Okay, so all the terms we'll be looking at for this first few days of this unit are all the sequences that we'll look at are arithmetic. They'll have common differences between each term. Okay, now what I want us to see here is, can we come up with a formula that allows us to, no matter what, define an arithmetic sequence. Okay, so let's try this. Okay, here's an arithmetic sequence. I'm going to call a sub 1 a sub 1. Okay, how would I go and find a sub 2? Well, what I would do is I would go back to the previous term, which is a sub 1, and I would add that common difference, which we call d. Okay. Now, what about a sub 3? Well, for a sub 3, what I would do is I would go back to the previous term, which would be a sub 2, and once again, I would add my common difference, which is d. Alright, well, look at this. A sub 2 is the same thing as a sub 1 plus d. So if I replaced a sub 2 with a sub 1 plus d plus this other d, what this becomes is a sub 1 plus 2d. Okay, d plus d, now I've got 2 d's. Alright, what about a sub 4? Let's do this a couple other times and then let's see if we see a pattern. Okay, to find a sub 4, we go back to the previous term, which is a sub 3, and we would add the common difference, which is d. Okay, well, what is a sub 3? We figured out a sub 3 is a sub 1 plus 2d. Okay, well, if I replace this a sub 3 with a sub 1 plus 2d, and then add this other d, well, now I've got a sub 1 plus 2d plus d is 3d. Okay, let's try one more here. A sub 5. How would I find a sub 5? I'd go back to the previous term, a sub 4, and I would add the common difference. We'll call it d. Okay, well, what is a sub 4? Here's a sub 4. Here's a sub 4. We found a formula for a sub 4. It's a sub 1 plus 3d. Okay, so what I'm going to do here is I'm going to replace a sub 4 with a sub 1 plus 3d plus this d. And what does this give me? A sub 1 plus 4d. Okay? So look at all of these different terms that we finished with when we're done. A sub 1, a sub 1 plus d, a sub 1 plus 2d, a sub 1 plus 3d, a sub 1 plus 4d. Let's see if we can come up with a formula that defines this. Okay? So just a general formula, which we're actually going to call our explicit formula for arithmetic sequences. Okay, our explicit formula for arithmetic sequences. Here's what it looks like. Okay, a sub n. Notice all of these have an a sub 1. Okay. Now, notice right here, I'll start with actually number 2, our second term. When we're on our second term, this is a 1 times d. When we're on our third term, it's a 2 times d. When we're on our fourth term, it's a 3 times d. When we're on our fifth term, it's a 4 times d. Well, what's happening? Every single time here we're multiplying by d. What are we multiplying by d? Well, we're taking the number of the term and we're subtracting 1. When we're at the fourth term, we're multiplying by 3. When we're at the fifth term, we're multiplying by 4. What would that look like? Well, n is the term. I'm subtracting 1. So here's what I've got. Okay, a sub n equals a sub 1 plus n minus 1 times d. Okay? This formula right here will work for any arithmetic sequence. So for example, let's say that we had something like, let's say 3, 7, 11, 15, 19, and so on and so forth. Well, if we wanted to come up with an explicit formula for this, here's what it could look like. A sub n equals, what's the first term? Well, my first term here is 3 plus n minus 1. And what's the common difference here? Well, each time here we're adding how much? 4, 4, 4, 4. So my common difference here is 4. Alright? We just want to do a little bit more work with this to clean this up. All we need to do is we need to distribute this 4 right here. Okay, so this becomes 3 plus 4n minus 4. And when we combine our like terms here, 4n is going to stay the same, but 3 minus 4 gives me a minus 1. So an explicit formula for this particular sequence could be 4n minus 1. Okay, we start out right here, distribute, clean it up a little bit, and now we've got this. Okay, so this makes sense. Like if I want to know what's the third term of this sequence, well, the third term is definitely 11. If I check that here, 4 times 3 is 12, minus 1, that gives me 11. Okay?